Alright, the one with the funny looking little critter, that is a Cyclops. And so they give us some information in part 6. An aquatic arthropod called a Cyclops has antennae that are either smooth or barbed. The allele for barbed is dominant. In the same organism, resistance to pesticide is a recessive trait. Make a key to show all the possible genotypes and phenotypes of this organism. Use the rabbit key to help you if you are lost. So our first trait that we're looking at is the trait for barbs. And they're telling us that barbs is dominant, and we can either have smooth or barbed. And so if the dominant trait for that is barbs, the letter we usually choose is that of the dominant trait, and so for this one I'm going to use B. Now in all honesty, you can use any letter of the alphabet that you want, but the tradition is to use the letter of the one that's dominant. So if barbs is dominant, that means that big B would be barbs, and big little would also be barbs, and then little would be smooth. On our other traits, the resistance to pesticides is recessive. So resistance to pesticide is recessive. So I guess non-resistance would be dominant. So if I did non-resistance, I could use the letter N. So big N would be non-resistant, as would big N, little n. And resistant is recessive, so little n would be resistant. And sorry we didn't give you much space to do that, that's why I'm doing it in the margin. So in 7, a Cyclops that is resistant to pesticides and has smooth antennae is crossed with one that is heterozygous for both traits. Show the genotypes of the parents. So our first one is resistant to pesticides and has smooth antenna. So our smooth antenna is little b, and our resistance to pesticides is little n. The other parent is heterozygous for both traits, so that means they would be big B and big N, little n. And then probably the hardest part of this is to set up a Punnett square for the top. Since this is a dihybrid cross, meaning that we're crossing two traits, we need to have the 16 square Punnett. So you're going to draw that out, and I know on your paper it's pretty small. If it gets to be too small of a space for you, you're welcome to use the space on the bottom. My concern is you just have it on the paper somewhere that we can see it. So we're going to write this one out as a 4x4 square. My OCD kids, I have rulers at the front of the room you're more than welcome to grab. I know it's going to probably drive you nuts that mine are not all equal right now. But the hardest part about this is actually setting up the cross itself. And so what are the possible gene combinations that could be donated? So with our letter B's, let's look at that first. The only option that our organism here could donate is the little b. So going across the top, it can donate little b to all its possible babies. The only one it can donate on the resistance is the little n, so all the possibles are little n. Now it's not quite so easy for the second parent. So if we look at the B's, they could donate a big B or a little b. So when I write these out, I like to do 2 big B's and 2 little b's, because out of, if we're doing our meiosis and you have like the 4 little sperm being produced, half would have big B's, half would have little b's. Now where it gets a little more complicated is with the second trait. So it can donate the big N's or the little n's. Now if I put big N up here, that means the big N always comes with the big B. And that's not the case. So when you do the second trait, I would do big N here and a big N with the little b down here. With the small n, that would fill in the other 2. So it's showing all the possible allele combinations that could come through meiosis to our offspring. Once you have it at this point, the rest of it's pretty easy. You're going to go through and do our combinations. So like right here, you would have big B, big N, little n. And you'd go through, so like down here would be little b, big N, little n, so on and so forth until you have all your squares filled out. Down below, what are the phenotypic ratios of the offspring? You would take all your possible phenotypes and write them out once you have your square done. We usually start with the largest number first and then work your way down to the number that you have the least of. And you won't know that until you do your square. And I have the key up at the front once you get that far, and you can come up and check it and see if you're right. Thanks.